Why not just version? The traditional approach to dealing with breaking changes in APIs is to use the notion of versioning. From the perspective of developing evolvable systems, it is useful to consider versioning as a last resort, an admission of failure. Assigning AV1 to your initial API is a proclamation that you already know it cannot evolve and you will need to make breaking changes in your V2. However, sometimes we do get it wrong. Versioning is what we do when we have exhausted all other options. The techniques discussed in this book are to help you avoid the need to create versions of your API. However, if and when you do need to version some piece of your API, try to limit the scope of that declaration of failure. Do not interpret this guidance as saying you must do big design up front and get everything right the first time. The intent is to encourage an attitude of minimalism. Don't specify what you don't need to. Don't create resources you don't need. Evolvable APIs are designed to change so that when you identify new things that must be added, you can do it with minimum effort. Versioning involves associating an identifier to a snapshot of an API, or some part of an API. If changes occur to the API, then a new identifier is assigned. Version numbers enable coordination between client and server so that a client can identify whether it can communicate with the server. Ideas like semantic versioning have created ways to distinguish between changes that are breaking and those that are non-breaking. There are several ways to use versioning within evolvable systems with varying degrees of impact severity. Versioning can be done within the payload, for example, XML, HTML. With the payload type, for example, application/bnd.acme.foo.b2xml. At the beginning of the URL, for example, /b2/API/foo/bar. At the end of the URL, for example, /API/foo/bar.b2. What changes are considered breaking? It would make life really easy if we could classify API changes into breaking and non-breaking buckets. Unfortunately, context plays a large role in the process. A breaking change is one that impacts the contract, but without any hard and fast rules of what API contracts look like. We are no further ahead. In the REST architectural style, contracts are defined by media type and link relations, so changes that don't affect either of these should be considered non-breaking. And changes that do affect these specifications may or may not be breaking. Payload-based versioning. One of the most important characteristics of the web architecture is that it promotes the concept of payload format into a first-class architectural concept. In the world of RPC, parameters are simply an artifact of the procedural signature and do not stand alone. An example of this is HTML. HTML is a largely self-contained specification that describes the structure of a document. The specification has evolved hugely over the years. The HTML-based web does not use URI-based versioning or media type versioning. However, the HTML document does contain metadata to assist the parser in interpreting the meaning of the document. This type of versioning helps to limit the impact of version changes to the media type parser codebase. Parsers can be created to support different versions of wire formats, making support for older document formats fairly easy. It remains a challenge to ensure that new document formats don't break old parsers. Versioning the media type. In recent years, The idea of versioning the media type identifier has become popular. One advantage of this approach is that a user agent can use the accept header to declare which versions of the media type it supports. With well-behaving clients, you can introduce breaking changes into a media type without breaking existing clients. The existing clients continue asking for the old version of the media type, and new clients can ask for the new version. Opaque identifier. From the perspective of HTTP, what is being done is not really versioning at all, it is simply creating a brand new media type. As far as HTTP is concerned, media type identifiers are opaque strings, so no meaning should be inferred from the characters in the string. So, in effect, application/vnd.acme.foo is no more related to application/vnd.acme.foo.b2 as it is to text/plain. The identifiers are different, therefore, the media types are different. The fact that the parsing library for the two versions might be 99% similar is an implementation detail. A downside to using media types to version is that it exacerbates one of the existing problems with server-driven negotiation. It is not unlikely that a service may use many different media types to expose a wide variety of content, requiring that a client declare, on every request, all of the media types that it is capable of rendering adds a significant amount of overhead to each request. Adding versions into the mix compounds that problem. If a client supports v1, v2, and v3 of a particular media type, should all of them be included in an accept header in case the server is only capable of rendering an old version? Some user agents have started to take the approach where they only send a subset of media types in the accept header, depending on the link relation being AC. This does help reduce the size of the accept header, but it introduces an additional complexity where the user agent must be able to correlate link relations to appropriate media types. Versioning in the URL. Versioning in the URL is probably the most commonly seen approach in public APIs. To be more precise, it is very common to put a version number in the first segment of a URL, for example, http://example.org/v2/customers/34. It is also the approach most heavily criticized by REST practitioners. The objection is usually related to the fact that by adding URLs with a new version number, you are implicitly creating a duplicate set of resources with the new version number, while many of those resources may not have changed at all. If URLs have previously been shared, then those URLs will point to the old version of the resource rather than the new version. The challenge is that sometimes this is the desired behavior and other times it is not. If a client is capable of consuming the new version, it would prefer the new one instead of the old version that it bookmarked. If the resource with the new version is actually identical to old version, then it introduces a new problem where there are two distinct URLs for the same resource. This has numerous downsides when you are trying to take advantage of HTTP caching. Caches end up storing multiple copies of the same resource, and cache invalidation becomes ineffective. An alternative approach to URL versioning is appending the version number near the end of the URL, for example, http://example.org/customer/v2/34. This allows individual Sources to be versioned independently within an API and eliminates the problem of creating duplicate URLs for identical resources. Clients that construct URLs have a much more difficult time consuming this type of versioned URL, because it is not as simple as just changing the first path segment in all request URLs. Hypermedia-driven clients can't even take advantage of this type of versioning because URIs are opaque to them. New resource versions must be identified via a versioned link relation to be accessible to this type of client. Versioning of APIs is a difficult topic that has many pitfalls. Making the effort to avoid versioning as much as possible will likely provide many long-term benefits. Walking the walk so far in this chapter, we